So we're going to do a quick review of solving systems of equations, and I want you guys to focus mainly on elimination because that's how what's going to carry us through the next part. It's a little bit harder. When we do elimination, the goal always for solving systems is try to get one equation with one unknown. Here we have two equations with two unknowns. We're going to take the route today of trying to get these y's to eliminate. It'll be the fastest thing to do because I can get these to have opposite coefficients pretty easily if I make everything in this equation negative 2 times bigger. I do want to point out, you could just as easily, not just as easily, but with not too much more work, instead get rid of these x's by finding something that both 5 and 8 go into, which would be 40. So maybe you can multiply everything in this equation by 8, everything in this by 5, you can work it through that way. But we're going to go the easier route right now and just get these to be opposites. So what I'm going to do is leave the top equation alone, because it's already got the 6 in front of the y, which is what I want. I want some version of 6 in front of y. And then for that second equation, everything will be negative 2 times bigger. This, and this, all multiplied by negative 2. So that's going to give me a 16x, a negative 6y, and finally a negative 40. So now that these guys are exact opposites, I can just go ahead and combine the two equations together, and these will drop out, and I'll have one equation, one unknown. So 16 plus 5 makes a 21x, and then negative 40 and 19 combine to make negative 21. And now this is the type of equation you saw back in pre-algebra, and you get the x by itself. I'll divide both by negative 21, so x therefore equals negative 1. Now that I know what the x value is, I can go back into either equation, this one or this one, with this x equal to negative 1 to find the appropriate y value. So just for kicks, I'll pick this one. I know x is negative 1, so 5 times negative 1 is negative 5, plus 6 times some weird y value equals 19. Still back in pre-algebra, trying to solve this for y, I'll go ahead and add 5 to both sides to give me 6y equals 24. And then finally, to get this y by itself, I'll divide both sides by 6. And when I do that, I get y equals 4. So that's my final answer. An ordered pair, negative 1, 4.